Welcome to my YouTube channel. In this video lecture, we are going to answer questions from question 41 to question 50 from time chapter in Keith Williams. So let's begin. Question 41, simple. Two aircraft are flying eastwards along around the earth. Aircraft A is flying along 60 north parallel of latitude and aircraft B is flying along the equator. If aircraft A is flying at a speed of 240 knots, what would be the ground speed of aircraft uh, in the same journey time? So first, let's consider aircraft A and its journey. So aircraft A is going to fly around 60° north latitude, entire 360° on 60° north latitude. Okay, so this aircraft makes a complete 360° turn rotation around 60° north latitude. So this complete rotation will be your rumline distance. What is rumline? Rumline is nothing but when you follow a particular latitude east or west. So rumline distance is d long in minutes into cos lat. So d long. So here you are making a full 360° rotation. So difference between the longitude will be 360° into 60 into cos 60. So that will be 360 into 60 into cos 60, 10,800 nautical miles. Now you have distance, you have speed with you. Speed is 240. So what will be the journey time? Distance by speed, 10,800 divided by 240, 45 hours. 45 hours. Now we have to find out the speed that will be taken by the next aircraft, some other aircraft which will be making a full 360° turn at 0° equator. Okay, so there is another aircraft located at 0° equator and that aircraft is going to make a complete 360° turn. Okay, and it is going to achieve that in the same time, 45 hours. The distance, now this distance, line distance will be different from this because the latitudes have changed. Okay, so line distance will be d long in minutes into cos lat, that is 360° into 60 into cos 0. So 360 into 60 is 21,600 miles. So now you have time and distance. With this you can obtain speed, distance by time. So 21,600 divided by 45 is 480 knots. Just 480 knots. So the correct option will be what would be the ground speed of aircraft B Bravo? It would be 480 knots, much more than 240 knots. Why? Because it has to cover much more distance in the same journey time. So that's why the speed has increased. Circumference of the earth, remember it is 21,600 nautical mile or 40,000 kilometer. Next, the sun rises at 55 north, 50 east on 25th of January at 0254 UTC. On the same day, what time does it rise? At 55 north, 40 west. So there are two longitudes, 40 west and 50 east, right? So at 50 east, the sun rises at 0254 UTC. It will rise at what time? At 40 west longitude. Now 40° west longitude is west of 50° east longitude. Western longitudes are behind in time compared to their eastern longitudes. Therefore, sunrise at 40 west will be sunrise at 50 east plus the time difference between these two longitudes. Okay, so if sunrise happens at 0254 UTC at 50 east longitude, sunrise at 40 west will happen much later than 0254. What is d long between these two longitudes? It is equal to 90 degree. 40 plus 50, 90 degree. That translates into time difference of 90 by 15, that is 6 hours. Substitute the values here. Sunrise at 40° west longitude will be equal to sunrise at 50 east 0254 plus time difference of 6 hours, so 0854. So sunrise will happen at 0854 UTC. Next, question 44. The sun sets at 9. Let me check this question. Question 44. Question 44. Uh, so longitudes are 45 north, 25 east. 31st March 1633 UTC on the same day at 45 north, 60 west. So again, similar question. So again, we have two longitudes, 60 west and 25 east. D long is equal to 60 plus 25, 85 degrees. The time difference will be equal to 85 divided by 15, 5 hours 40 minutes. So at 25 east longitude, the sunset timing is 1633 UTC. So at 60 west longitude, the sunset timing will be much later. Okay. So sunset at 60 west longitude will be equal to sunset at 25 east plus the time difference between them. Why? Because 60 west is to the west of 25 east. Western longitudes will be behind in time compared to their eastern longitudes. Therefore, sunset will happen at 60 west longitude much later than 1633. So 1633 plus 0540, 22 hours 13 minutes. So this is the answer. You can convert this 22 hours 13 minutes UTC into corresponding LMT time. I have done that in the previous question, so do watch those videos. Now the sun rises at 50 north, 25 west on 25th Jan at 6:54 UTC. At what time will it rise at 40 east longitude? Similar question. So there is a 25 west longitude, there is a 40 east longitude. At 25 west, the timing is 0654. At 40 east, it will be what? Now, 40 east longitude is to the east of 25 west longitude. Eastern longitudes are ahead in time compared to their west longitudes. Okay, compared to their west longitudes. So sunrise will happen much earlier at 40 east longitude than 25 west longitude. Okay, so right here I'm going to write here sunrise at 40 east will be sunrise at 25 west minus the time difference between them. I minus because sunrise at 40 east will happen much before 6:06:54. Now the time difference between them is D long is 25 and 40, 65. So time will be 65 by 15, 4 hours 20 minutes. So 0654 minus 0420, 6 hours 54 minutes minus 4 hours 20 minutes, 2 hours 34 minutes UTC. So this is the final answer. Two aircraft similar to question number 1 are flying eastwards around the earth. Aircraft A flies at 50 north parallel of latitude. And aircraft B flies around the equator. Now first consider aircraft A. Situation 1 where aircraft A flies around 50 north parallel of latitude at 340 knots. At 340 knots. Now the total distance in making a 360-degree rotation will be your rumline distance. Rumline distance of D long in minutes into cos lat. So 360-degree D long into 60 into cos 50. 360 into 60 into cos 50 is 13,884 nautical miles. So distance is 13,884. Speed is 340. Time will be distance by speed. That is 40 hours 50 minutes or approximately 50 hours or 41 hours. Now the aircraft which is located on the equator is also going to make a 360-degree rotation. So rumline distance will be D long in minutes into cos lat. So 360 into 60 into cos, equator is 0. Okay, equator is 0. So this is 21,600 nautical miles. Now the time available for this aircraft is 40 hours 50 minutes, same journey time. So speed will be much more than this speed because it has to now work harder. Okay, cover much more distance in the same amount of time. The speed will be distance by time, which is 21,600 divided by 40 hours 50 minutes. That is 529 knots, or any other option which is close to this value, 529, 530 knots. Question 47. Again, one aircraft is flying around 45 north latitude and the other at equator. First aircraft is flying at 300 knots. What would be the speed of the second aircraft? So this is your Earth. There are two latitudes. One of them is 45 north. The second is equator 0 degree. For aircraft 1, the distance it will cover will be equal to run distance of b long in minutes into cos lat. So 360 into 60 into cos 45. 360 into 60 into cos 45 is 15,273 nautical miles. Now time taken by this aircraft will be distance by speed. 15,273 divided by 300 knots. 50 hours, 54 minutes. Now the distance covered by aircraft at equator will be equal to 360 into 60 d long into cos lat cos 0. So 21,600 nautical miles. The time available for this aircraft is 50 hours 54 minutes, same time. So speed will be distance by time 21,600 divided by 50 hours 54 minutes. That is 424 knots. 424, 425 knots. Question 48. Now there are two aircraft. One is flying at 60 north latitude and other is flying at 20 north latitude. Aircraft first is flying at 240 knots. What would be the new speed of second aircraft flying at 20 north latitude? So this is your Earth. One latitude is 60 north. Second latitude is 20 north. Let's consider the aircraft. First, let's consider aircraft flying at 60 north latitude. So the distance covered by it will be equal to b long in minutes into cos latitude. So full 360-degree rotation, that means 360 degree into 60 minutes into cos of 60. So it's 10,800 nautical miles. Speed of this aircraft will be 240 knots. So time will be distance by speed 10,800 divided by 240, that is 45 hours. Next, now let's go to aircraft number 2. This was aircraft 1. Now for aircraft 2 we have time, same journey time 45 hours. The distance will be drumline distance 360 degree into 60 minutes into cos 20, cos latitude, so 20. 360 into 60 into cos 20 is 20,297 nautical miles. So speed will be equal to distance by time 20,297 divided by 45 hours. That is equal to 451 knots. 451 knots. So the speed of second aircraft will be 451 knots. Next, two aircraft are flying at 75 north latitude. So one is at, and both are flying at 75 north. Second aircraft is flying along 45 degree. Okay, so there is some printing error, but the question states that one aircraft is flying at 75 north latitude. Second aircraft is flying at 45 north latitude. So the speed of aircraft number 1 is 300 knots. Okay. The distance covered by it will be d long in minutes. .360 into 60 into cos 75. So that gives us a distance of 5590 nautical miles. The time will be distance by speed 5590 divided by 300 knots. That is 18 hours 38 minutes. Okay. Next, the time available for aircraft number 2, which is going to make a full 360-degree rotation at 45 north latitude, is going to remain the same, which is 18 hours 38 minutes. Distance 360 degree into 60 minutes into cos latitude, cos 45. So 360 into 60 into cos 45 is 15,273 nautical miles. So now the speed of this particular aircraft will be distance by time 15,273 divided by 18 hours 38 minutes, which is equal to 820 knots, approximately 820 knots. Okay. So select that option which is closest to this option. Last question. Again, two aircraft. One is flying at 30 north, the second one at equator. The speed of first aircraft is 400 knots. What would be the speed of the second aircraft if both aircraft have the same time available? So again, this is your Earth. First aircraft is flying at 30 north latitude. The second aircraft is flying at 0-degree equator. So the speed of this first aircraft is 400 knots. Distance of this aircraft will be 360 into 60 rumline distance, d long into cos lat. So cos 30. So 360 into 60 into cos 30 is 18,706 nautical miles. Time will be distance by speed. So 18,706 divided by 400 knots. This gives you a time of 46 hours 45 minutes. Now second aircraft at equator has this same time available with itself, a time of 46 hours 45 minutes. The distance it has to cover will be 360 into 60 d long into cos lat 0. So 21,600 nautical miles. Now speed will be distance by time 21,600 by 46 hours 45 minutes. 62 knots. 462 knots. So the correct option will be option, whatever option that is close to this value, 462 knots, 463, 460. Okay, so simple questions, and do practice these questions many times. Sure short question. This question gets asked in CPL, ATPL, airline exams often. So don't miss this questions and practice them and know how to solve them and get the right answers every time you solve them. So I'll stop here. This concludes our lecture for this 10 questions, and with this lecture also we have finished solving all 50 questions from time chapter in Keith Williams General Navigation book. If you have any doubts, questions, let me know in the comment box. Watch all the videos, do all the questions, and I wish you all the best. Subscribe to this channel and share this video with your friends. Thank you.